Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. Now in this video we're going to be talking about the trapezoidal load, which means a load that is defined by 2 points and 2 load values. In a nutshell, we're going to define trapezoidal loads. Now of course, if you're wondering, this is part of a multi-parter series about the finite element method, which you will see the link of it in the top right. Also, this is part of its own standalone video series in programming, which is also on the top left. Check out those video series if you want to exactly know how we reached here. Now, if you are interested in the source code is available only to my dear channel members. However, if you're not a channel member, then don't worry, because every single line of code available to my dear channel members is written here, so you can write along and have the exact same code. And with that being said, and without further ado, sit back, relax, and enjoy the show. Alright, now we're going to talk about linear load distributed. So the linear load distributed is basically a load that is applied on a bar that has a starting value and an end value, a starting position and an ending position. Now the starting value can be fx, fy, fz, mx, my, and mz. And the ending value the same. So to achieve that, I would need to define multiple things for the linear load. I would need, for example, to define the 6 values of load at the beginning, the position of the beginning, and the 6 values of the load at the end, and the position of the end. Meaning, it's kind of the line load concentrated, but multiplied by 2. And that's what I will be doing right now. So, here I have my line load concentrated, the stuff I was talking about in previous videos. I'm going to click on plus and save, and this is going to be called str line load distributed. I save, and now I'm going to take the concentrated, Ctrl A, Ctrl C, copy, and then go to linear load, Ctrl V. Now remember, for a linear load distributed, I would need 2 values for each load value and 2 values for each location value. So instead of fx, it's going to be fx1, fy1, fz1, mx, my, and mz1. You could call it start and end if you want. I think it's even more appropriate to call it start and end, despite the fact that it will take me more time to write. But well, it's better to look cool. The applied to will not change. I put it down here, but the relative location will have a start and an end. So that's the start. And now I need to copy and paste and change the start to end. So I push the button here and basically change this to end. So I need to copy this and then change every single one of those to end. Those are the properties of the str line load distributed. Now in the constructor, of course, I'm going to call the same function, the same class name, and here I need the user to give me the starting values and the ending values of each one of those things. So you can see me appending an s here, which is basically start, because I'm too lazy to write start, and then fxe, fye, fze, e for E stands for end, mxe, mye, and mze, of course, relative location e. Those are the inputs that must be inputted to define this load. Now I need to take this stuff and basically input it here. So I copy this entire thing first, because I want to use a speed hack very quickly. Here I'm going to write start, I'm going to copy this stuff and paste it for the next values. There we go. And now I'm going to write end and copy it and paste it for the next values. So this is end now. And here I'm going to add me s's for the starts, because those are the input values provided to the constructor. And here I will provide e for end, because those are once again the input values provided by the constructor. Fantastic. Now when I want to report it, I would need to have 2 ats. I would have to have an at for start, and then maybe 2 arrows, and then an at for the end, so dash 4.2f. And here I would have relative location start and object.relative location end. Fantastic. Now here I must, of course, report everything. So I'll copy this first to kind of speed up. Maybe I should just do this. S, or just 2 arrows maybe. Yeah, I think this makes more sense. I want to preserve the vertical space. 5.2F. Yeah, something like this looks neat. So I just copy this, paste it everywhere, and then implement it. So this is start, and then object.fxend. Same thing applies for this. This is start and object fyend. I think I can copy this to kind of speed up my work. So Control V, Control V, Control V, Control V. This becomes Z. This becomes an X. That's a Y. I think this is good enough. So let's put it to the test. Without the controller, define the load. So line load distributed 1. This is going to be the controller. No controller. We haven't reached that position yet. str line load distributed and off. Let's give it an ID, -1. Let's copy those values because I'm kind of lazy. So I'll copy those values, and then I am going to push the enter key for the end values, but I'm going to change the values. So now this is going to be 500, that's going to be 2000, that's going to be 1000, that's going to be 200, 400, and 100. And that's 0.6. Okay, now I'm going to ask it to report itself. So, to string, and let's see what happens. And see if we successfully defined distributed loads. F5, of course it's reporting everything now. Let's take a look in the beginning. And line load concentrated -1, start 0.4. Why at? I think there should be an E there. So let's go here and take a look at the reporting system. So here, my fault, I put an at here. Let's put an E here and run again. So line load concentrated, ID -1, start 0.4, end 0.6. Now for the X, 2500, 1200, 500, 1000, 400, 200, 300, 400, 200, 100. Yeah, that worked perfectly. Fantastic. And I think for the next video, I'm going to implement this in the str controller. But that's a discussion for next time. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And in the end, I want to give a distributed load sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support to the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is a Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.